When trying to test what type of relationship you would have in your population, we can, instead of testing for the slope, we could actually test for the population correlation instead, and that will allow us to see if we have a linear relationship in the population. Even though the formulas look different, it turns out these are equivalent and they will give us the same test stat. And so in example 9.1.2, we are just going to show that we get the same test statistic if we do the correlation approach as opposed to the slope approach we did in the last example. So our test statistic that we use when we're testing for a population correlation is t equal to sample correlation, which we're told is negative 0.2693, times the square root of n minus 2, so this would be the square root of 251, over the square root of 1 minus our correlation squared. So when we square the negative 0.2693, it becomes positive, but we are still subtracting off that number. These two pieces separately, the numerator and denominator, are these two values. And so we end up with negative 4.43. We would be testing here rho, which is our population correlation, equals 0 versus not equals 0. And this, if we compare this to what we got in the previous example, is matching. It's the same number. So this matches the test stat for slope. So the rest of the test would be the same. When we would go look up our p-value, we would get that same 0.000014, and we would still reject the null and say that we have evidence of some linear relationship between drinks and GPA in the population. So to test for a linear relationship in the population, you can either test for slope or test for correlation. They are equivalent.